last video we looked at how we can deseasonalize demand data, and we have estimates now for that deseasonalized data. We're going to use those estimates to run a regression or to create an estimate of deseasonalized demand as a function of time. That process is going to identify an intercept, which is this level that we were speaking of in the last video, and the intercept is the level, the slope is the trend. So we're going to, in this video, look at how to do this regression analysis, and then we'll use our regression results to get an estimate of dt bar for all values of t. So let's get started. Here's the data as we finished last time. We have an estimate for dt bar, but only from July of the first year through June of the last year. Apparently, though, I want something for every time period as an estimate for demand. To do that, I need to estimate a regression equation using our d bar sub t's and time. So use the data analysis tool pack under the data tab. Now the data analysis tool pack is not standard, so if it's not on your machine, go to File, Options, Add-ins, Go, click the analysis tool pack, choose OK, and then your data analysis tool pack will show up on the data tab. So let's go ahead and click it. In that data analysis tool pack, what you're looking for is something that says regression. Choose regression and then start walking through the questions. Where are my y values in my regression? Well, those are the estimates that we finished last time we were on the last video, so I can highlight them. I need to do the same with the x values. Those are the time values that are associated with these day bar sub t's. I don't have any labels. We can't include them because of these blank spaces. I do want the output to live somewhere in this sheet, so choose the output range and place it in a cell on this data tab. And then I'm going to push OK. And I get my summary output. In this summary output, this intercept term, that is the level I'm looking for, and x variable 1, that is the trend, or t, that I'm looking for. So I can use this estimate, these intercept and slope, to get a t bar for every time period. So that's equal to the intercept, make that an absolute reference, plus the slope, make that an absolute reference, times the value of time. So time period 0, my d sub 0 bar, 6,067 and a half. I can then, if I've got that, because of my absolute references, I can just copy that all the way down. I may want to back this up to here, what I have data for over here. Okay. So these are my demand estimates with the seasonality taken out. Now, I don't want to leave the seasonality out. That would be a bad choice because, this says my forecast is 6,137 units for February of the first year. Well, the actual amount was 3,000. Oh, that's a bad forecast. So how do I improve it? If you go back to what we were looking at here, what I have is the level, the trend, and what I need is this seasonal factor. The seasonal factor is given in the textbook, but it is initially equal to the actual demand divided by that deseasonalized demand. Okay. So there's my estimate for the seasonal factor in January of the first year. Notice how this number varies. And really what we're going to do in our forecast is we're going to take this demand forecast and we're either going to compress it, squeeze it down, or for example like here, we're going to take that demand forecast and expand it, make it bigger. Okay. Well, we're almost done with the seasonal variables. What I need now, or to complete that, is I need table number, and I need a seasonal factor, S sub I. Okay. Well, here's how I get that S sub I. I'm going to take the seasonal factor for every January, and I'm going to average all of the January seasonal factors. I have 5 of them because I have 5 years. So I'm going to divide those things by 5. Okay. So for January, the average seasonal factor, as defined in your textbook on page 186, equation 7.6. For January, the seasonal factor is 0.42. So in essence, what it's saying, if I ignore the seasonal factor, I'm going to ask for 6,067 units to come to my store in January of the first year. But the seasonal factor says, well, you should shrink that by about 58% in order to get closer to the actual number. We'll see how that works here more in a second. Okay, so February, March, let's get this all the way through December. If I entered this function correctly, I should be able to just copy it down through the other months. Okay. Notice that some months I'm compressing, some months I'm expanding my actual trend. I am altering my trend factor, my trend estimate of demand. Okay, well, I'm going to add another column. Why? Because it makes life a little easier. I don't know what you know about modular arithmetic, but I want to do this. I'm gonna do equals mod t comma 12. What it's doing is it's dividing t by 12, and then the number it puts there in cell H2 is the remainder. So, if I divide 0 by 12, I get 0 with 0 remainder, so I should get a 0. If I divide 1 by 12, I should get a remainder of 1. Okay, so if I divide 12 by 12, I should get a 0. So notice that every time January comes up, there's a 0. Every time January comes up, there's a 0. Okay. Every time January comes up, there's a 0. Okay, now let's go after the forecast. So my forecast is equal to the level, fix that, an absolute reference, plus the trend, another absolute reference, times time. And then take that answer, stretch it by the seasonal factor. Well, I'm going to get the seasonal factor as follows. I'm going to use the VLOOKUP function. VLOOKUP. What is it going to look up? I'm going to have it look up this number I calculated using modular arithmetic, and I'm going to have it go to the table that we created with the seasonal factors, I'm going to make that an absolute reference. I'm going to make it look for the number 0 in the second column. Then I'm going to turn in false. False makes it have to absolutely match 100%. Because notice what happened in this forecast for year 1, January. What it did is it said if we ignore the seasonality, we would have ordered 6,067 units, but we only sold 2,000. Well, if I stop ignoring the seasonal factor, what I do is I compress or reduce this d sub t, d sub 0, I compress it or reduce it by 58%. Okay. Now I should be able to just copy down. And I also should be able, let me extend this. This is not right. Well, that's alright. That's not. Let me get a forecast for the next 12 months. So let me highlight this so we see that's what we're forecasting. Okay, there we go. There's my forecast for the 6th year, for the entire year, month by month.